Let's look at this next problem. You notice you got denominators? Remember what I mentioned in a previous lecture? Yeah, it's quicker to solve an equation and an inequality when there's no denominators. Okay? So, again, there's two different ways to do this. I am going to do it the way that I showed in a previous lecture. So we want to get all these denominators the same first. Okay? So for some of us, this is the best way to do it. So I have to make sure I put a 1 under there so I know it has a denominator of 1. What's the common denominator between a 3, a 7, and a 1? Good. 21. So that means first fraction, top and bottom, need to get multiplied by 7. Second fraction, top and bottom, need to get multiplied by 3. And last fraction, top and bottom, needs to get multiplied by 21. Agreed? Okay, so next line. Multiply the numerator by 7. I get 7 minus 14x over the 21 plus 9x plus 21 over 21 is greater than or equal to 21 over 21. Okay, now that all the denominators are the same, now at this point, it's very easy to get rid of them. And the way I'm going to get rid of these denominators of 21 is to do what? Yeah, we're going to multiply the whole inequality by 21. By the way, I'm multiplying the entire inequality by a positive 21. So does the inequality sign flip? No, it does not. Remember, the only time the inequality sign flips is when you multiply by a negative number. Good. So these guys are going to cancel. And let's see what remains. I have 7 minus 14x plus the 9x plus 21 greater than or equal to 21. Cool? Okay, now this is very quick for us to solve, isn't it? Because there's nothing hiding the problem. There's no parentheses, there's no fractions, easy peasy. So time to collect like terms, yes? Okay, so I have a negative 14x and a positive 9x. Yeah, that's negative 5x. And I have a positive 7 and a positive 21. Good, positive 28, greater than or equal to 21. Now what? Move the 28 over. Excellent. So I have negative 5x greater than or equal to negative 7. And then what? Yeah, I'm going to have to divide by a negative 5. So, the left side, these cancel, and what remains is x. The right side, they don't reduce, but a negative divided by a negative is a positive. But since I divide by a negative number, does my inequality remain the same? Excellent, it does not, it flips. So instead of being greater than or equal to, it is now less than or equal to. Got it? Okay, excellent. Yep, time to graph. So, again, I care only about the 7/5. I'm looking for numbers that are less than 7/5. So those are all the numbers on the left, all the way out to negative infinity. And so, what's the interval notation look like? Good. My shading starts at negative infinity, which is going to get a parenthesis. My shading ends at 7/5. Oops, 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 oops. Yeah, some of you said, you're not done with your shading. You're right, I wasn't done with my shading. Because what am I supposed to put on the 7/5? A parenthesis or a bracket? Good. A bracket because it says equal to. So in the interval notation, yeah, I get to put that bracket. Cool? All right, good. Good catch, you guys. That's why I need you guys doing this stuff with me. Okay, so hang in there. I'll be back with some stories.